Okay, from the previous lecture, we learned how to draw the Lewis structure and how to determine the molecular shape and how to determine the molecular polarity. In this topic, we will learn about theory of covalent bonding, which involve valence bond theory and molecular orbital theory, and we can see also how the orbital overlap. Today, we only focus on valence bond theory, and when we talk about valence bond theory, it involves the missing of atomic orbital forming new hybrid orbital. Okay, according to valence bond theory, a covalent bond forms when two atoms overlap and the overlapping region is occupied by a pair of electrons, and it can accommodate a maximum of two electrons with opposite spins. Okay, here you can see how orbital on atom come together to form covalent. For example, 1s overlap with 1s orbital, and this electron come from one electron from 1s and another one electron come from another 1s orbital. And here you can see how 1s and 2p orbital, 1s from hydrogen and 2p orbital from F, and one electron from the hydrogen and one electron from the F. Okay, here you can see how the overlapping orbital of 2p orbital, and one electron come from 2p come from F, and another one electron come from another F, forming the covalent bond. Okay, hybridization is the process of orbital missing to form the new atomic orbital we call hybrid orbitals. Okay, here are the example how you use valence bond theory to explain the bond formation in CH4 molecule. Okay, as we know, CH4 has 4 covalent bond, right? So the electronic configuration of the center atom at the ground state is here. Okay, so as we can see here, it only has 2 unpaired electrons at 2p. So it cannot form 4 covalent bond. So what we need to do, we need to promote 1 electron from 2s here is promoted to 2p orbital here, and forming this electronic configuration of C at the excited state. Here, we only have to consider the electronic configuration of the valence orbital. Okay, and this valence orbital makes to form 4 new hybrid orbitals. Okay, why they mix? So that they can to get the maximum overlapping to get the strongest bond. Okay, as we can see here, the number of the hybrid orbital formed equal to the number of atomic orbital mix. Okay, as we can see here, the hybridization produce the hybrid orbitals that has lower energy compared to the atomic orbital. sp hybrid orbital is formed when s and p orbital of same atom mix and forming 2 sp hybrid orbital here, and this is the orientation of the 2 sp hybrid orbital with respect to the nucleus and each other. Okay, here are the example of sp hybridization in BeH2 molecule. Okay, this is the electronic configuration of Be, and as we can see here, the Be will contribute 2 electrons to form 2 covalent bond with hydrogen. Okay, but from the valence orbital here, we can see that it cannot form 2 bond, right? So what we need to do, we need to the electron from 2s here is promoted to 2p orbital, forming this, and this 1 2s one 2p orbital mix to form two new sp hybrid orbital. Here you can see one s orbital mixed with one p orbital forming two sp orbital, and the orientation for the two sp orbital is linear. And this is how the sp hybrid orbital, this is the orientation of the sp hybrid orbital in BE. And as we can see, the sp hybrid orbital contain one unpaired electron each, and this sp hybrid orbital will overlap with one s orbital that contain one electron each, forming two covalent bonds. Okay, here are the example of sp2 hybridization in BCl3 molecule. As we can see from the electronic configuration of B, we can see from the valence orbital, it can contribute 3 electrons to form 3 sigma bond with Cl. But in valence orbital, it cannot form the 3 bonds since it only has one unpaired electron. So what we need to do, we need to promote one electron from 2s to 2p orbital and forming this. Okay, so now there is 3 unpaired electron in 1 2s and in 2p orbital. Then what we need to do, we need to mix 1 2s orbital with 2p orbital, forming 3 sp2 forming new 3 sp2 hybrid orbitals that has unpaired electron. Okay, as we can see here, one s orbital mixed with 2p orbital forming 3 sp2 orbital, and the orientation is in trigonal planar. Okay, B will have 3 sp2 orbital, and this sp2 orbital will overlap with 3p orbital of Cl, which has one unpaired electron each, and thus forming 3 covalent bond. Okay, here are the example of sp3 hybridization in CH4 molecule. As we can see here, carbon can form 4 sigma bond with hydrogen, meaning that carbon can contribute 4 electrons to form 4 covalent bond with hydrogen. But from the valence orbital here, it only has 2 unpaired electrons, so it cannot form 4 bonds. So what we need to do, the electron from 2s here is promoted to 2p orbital, forming 4 orbital that has 4 unpaired electron, and this orbital 1 from 2s and 3 from 2p mix to form 4 new sp3 hybrid orbital that has 4 unpaired electrons. Okay, here you can see that 1s orbital mixed with 3p orbital forming 4 sp3 orbital, and the orientation is in tetrahedral. And here how the sp3 hybrid orbital in C overlap with 1s orbital of hydrogen, forming 4 covalent bond. Okay, here are the example of hybridization that involve lone pair electron, such as NH3 molecules. Okay, here we can see that NH3 it has 3 sigma bond and 1 lone pair. Okay, meaning that, and this is the valence orbital for nitrogen. Okay, since there are 3 sigma bond and 1 lone pair, thus it needs 3 unpaired electron and 1 pair electron. So 1 s orbital mixed with 3p orbital forming 4 sp3 hybrid orbital, where one of the sp3 hybrid orbital is filled with the lone pair. Okay, here are the result of missing one s orbital with 3p orbital forming 4 sp3 hybrid orbital. And we can see that one of the sp3 hybrid orbital is filled with lone pair electron, and another 3 sp3 hybrid orbital will be used for bonding. And these three hybrid orbitals that has one unpaired electron each will overlap with one s orbital that has one electron each, and forming three covalent bond. And we can see here that the n lone pair occupy sp3, giving a trigonal pyramidal shape. Okay, for example, water, it has 2 sigma bond and 2 lone pair. And the valence orbital for oxygen is like here. Okay, so since it has 2 lone pair and 2 sigma bond, so it requires 2 unpaired electrons and 2 paired electrons. So what we need to do is we need to mix one s orbital with 3p orbital to form 4 sp3 hybrid orbital, and 2 sp3 hybrid orbital will be occupied with the 2 paired electron. Okay, as we can see here, one s orbital mixed with 3p orbital forming 4 sp3 hybrid orbital, and 2 sp3 hybrid orbital will be occupied with 2 paired electron that represent lone pairs, and 2 sp3 will occupied with unpaired electron, and this will be used for bonding with hydrogen. Okay, as we can see here, the 2 sp3 hybrid orbital will overlap with 2 1s orbital of hydrogen, forming 2 covalent bond, and we can see here there is 2 lone pair here, and the shape for this molecule is band shape. Okay, here an example of sp3d hybridization for PCl5. Okay, first you must draw the electron configuration for central atom P and Cl. And from here we can see that it has 5 sigma bond, meaning that one P will contribute 5 electron and 5 Cl will contribute 1 electron each to form 5 sigma bond. Okay, from here, from the electronic configuration here, we only use the valence orbital to for hybridization. Okay, from here, we can see that it only has 3 unpaired electron, meaning that it only has 3 bond. It cannot form 5 bond. So what we need to do, we need to promote the 1 electron here to where? Since p orbital here has already full unpaired electron. So what we need to do, we need to promote the 1 electron from s orbital to empty d orbital. Remember, p is in group 3, so group 3 and higher has more, it has empty d orbital, so that's why this electron will be promoted to empty d orbital and forming this. Okay, so 1s and 3p and 1d orbital mix to form 5sp3d orbital that has 5 unpaired electron, and this will be used to form bonding with Cl. Okay, 1s orbital mixed with 3p orbital and 1d orbital forming 5sp3d orbital, and the orientation for sp3d orbital is trigonal bipyramidal. As we can see here, the sp3 the 5sp3d orbital of phosphorus overlap with 3p orbital of chlorine, forming 5 covalent bond. Okay, here are the example of sp3d2 hybridization of SF6 molecules, and we can see here it has 6 sigma bond, meaning the S will contribute 6 electron and F will contribute another 6 electron, forming 6 sigma bond. As we can see from the valence orbital of S, it has 2 unpaired electrons in the orbital, meaning that it cannot form 6 bonds. So what we need to do, we need to promote electron from S here and 1 electron from P here to the orbital. So 1s mixed with 3p orbital and 2d orbital, forming 6sp3d2 orbital that has unpaired electron. 1s orbital mixed with 3p orbital and 2d orbital, forming 6sp3d2 orbital, and the orientation for 6sp3d2 orbital is octahedral, and 6sp3d2 hybrid orbital of S overlap with 2p orbital of M, forming 6 covalent bond. This table summarizes the number and type of atomic orbital that mix to form 5 types of hybrid orbital. Please remember this. Okay, here are some steps converting molecular formula to hybrid orbital. First, you are given molecular formula, then you need to draw the Lewis structure and determine the molecular shape and electron group arrangement, and please refer table 11.1 to determine the hybrid orbitals that involve in the center atom. Here are the example of questions that require you to determine the hybrid orbitals, and you must show the hybridization process. Okay, first from the molecular formula you must draw the Lewis structure and determine the electron group arrangement around the center atom. For example here, C. Okay, C, the electron group arrangement around C is tetrahedral, and the electron group arrangement around O is also tetrahedral. Okay, since the electron group arrangement is tetrahedral, so the hybrid orbital that involved is sp3. So you must show the orbital diagram for isolated carbon atom and the orbital diagram for hybridized C atom. As we can see here, the 1 electron from S is promoted to p orbital to form 4sp3 hybridized orbital. And here, in order to form 4sp3 hybrid orbital, 1s orbital mixed with 3p orbital, forming 4sp3 hybrid orbital that have 2 paired electron in 2sp3 hybrid orbital that represent two number that represent two field with lone pairs. Okay, as we can see from SF4, the electron group arrangement is trigonal bipyramidal, so the central atom is sp3d hybrid orbital. And from here we can see that it has 4 bonds and one lone pair electron, meaning that it in orbital diagram it must have 4 unpaired electron and 1 paired electron. But from the isolated S atom in the ground state, we can see that it only has 2 unpaired electron, so it cannot form 4 bond. What must we do? We must promote 1 electron from this to d orbital, to one of the empty d orbital here, forming and S mixes 3p orbital and 1d orbital forming sp3d. Okay, so one of the sp3d consists paired electron that represent the lone pair, and these four unpaired orbital, these four sp3d orbital that has unpaired electron will be used for bonding with F. Okay, there are some limitations of the hybridization. For example, here, according to uh, according to the VSPR theory, the bond angle is predicted around less than 109.5, but the observation doesn't support this, while we get the angle is 92 degrees. Besides, d orbital don't mix effectively with s and p orbital, which are much lower in energy and more stable.